When installing an alternating current variable frequency drive, the temperature ratings of both the drive terminals and the connecting wires are important considerations for ensuring safe and reliable operation. In this specific scenario, the drive terminals are rated at 75 degrees Celsius, and incoming power feed utilizes THHN wire, which is rated at 90 degrees Celsius. The question arises whether the current carrying capacity of the THHN wire needs to be derated to 75 degrees Celsius because of the lower temperature rating of the drive terminals. The answer is no. You do not necessarily have to derate the current carrying capacity of the THHN wire to 75 degrees Celsius solely because the drive terminals are rated at 75 degrees Celsius. The fundamental principle is that the current carrying capacity of a wire is determined by the temperature rating of the wire itself, not the temperature rating of the device to which it is connected. In this case, the THHN wire has a 90 degrees Celsius rating, which exceeds the 75 degrees Celsius rating of the drive terminals. This means the wire can safely handle a certain amount of current at either temperature based on its own insulation properties. However, there is a crucial caveat. While the wire itself can handle the current without derating based on its 90 degrees Celsius rating, the drive terminals might not be able to handle the same amount of current. The current carrying capacity of the drive terminals depends on their internal construction and the size of the wires they are designed to accommodate. If the drive terminals are not rated for the same current as the wire is capable of carrying, the terminals could overheat, potentially leading to failure. Therefore, it is essential to consult the manufacturer's specifications for both the wire and the drive to guarantee appropriate wire sizing for the application. In general, electrical codes such as the National Electrical Code, or NEC, provide guidelines for selecting appropriate wire sizes based on ampacity, which is the current carrying capacity of a conductor in amps. The ampacity of a conductor is affected by several factors, including its material, size, insulation type, and the ambient temperature. NEC Table 310.15. V16, or its equivalent in other electrical codes, provides ampacity ratings for various types of conductors based on their size and insulation type, assuming an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. When the ambient temperature exceeds 30 degrees Celsius, a correction factor must be applied to the ampacity rating to account for the increased heat. These correction factors are also provided in NEC Table 310.15. V16. In addition to ambient temperature correction, derating factors may also be required when multiple current-carrying conductors are bundled together in a raceway or cable. These derating factors are specified in NEC Table 310.15. B3. The purpose of these derating factors is to prevent overheating of the conductors due to the combined heat generated by multiple current-carrying conductors in close proximity. When selecting a wire size for a particular application, it is essential to consider all applicable correction and derating factors to ensure that the wire is properly sized to carry the required current without overheating. In the case of the alternating current variable frequency drive installation, the selection of the THHN wire size should be based on the load requirements of the drive, taking into account any applicable correction and derating factors. The wire size should be selected such that its ampacity is sufficient to carry the load current without exceeding the temperature rating of the wire or the drive terminals. Even though the THHN wire is rated for 90 degrees Celsius, the drive terminals are only rated for 75 degrees Celsius. This means that the wire temperature at the point of connection to the terminals must not exceed 75 degrees Celsius. To ensure this, the wire size may need to be increased beyond what is strictly required by the load current to provide additional surface area for heat dissipation. Alternatively, a heatsink or other cooling device may be used to reduce the temperature of the wire at the point of connection to the terminals. In addition to temperature ratings, it is also important to consider the voltage rating of the wire. The voltage rating of the wire must be equal to or greater than the voltage of the circuit in which it is being used. In the case of the alternating current variable frequency drive installation, the voltage rating of the THHN wire must be equal to or greater than the voltage of the incoming power feed. Finally, it is important to follow all applicable electrical codes and standards when installing electrical wiring. These codes and standards are designed to ensure the safety of people and property. Failure to follow these codes and standards could result in fire, electric shock, or other hazards. Here's a more detailed breakdown of the factors to consider and the steps to take. Firstly, determine the load requirements of the variable frequency drive. This involves identifying the full load amps flaw of the drive, which can be found in the drive's nameplate or in the manufacturer's specifications. The FLA represents the maximum current the drive is designed to draw under normal operating conditions. Secondly, calculate the minimum ampacity of the conductors. The NEC specifies that the conductors supplying a motor, and in this case a drive, must have an ampacity of not less than 125% of the motor's full load current flaw. This is to account for the potential for overloads and to ensure that the conductors can safely carry the required current. To calculate the minimum ampacity, multiply the FLA by 1.25. For example, if the FLA of the drive is 20 amps, the minimum ampacity of the conductors would be 20 amps multiplied by 1.25, which equals 25 amps. Thirdly, select the appropriate wire size based on the calculated minimum ampacity and the temperature rating of the wire. Using NEC Table 310.15. V16, find the appropriate wire size for THHN wire with a 90 degrees Celsius temperature rating that has an ampacity equal to or greater than the calculated minimum ampacity. For example, if the minimum ampacity is 25 amps, a 12 American wire gauge, or AUK, THHN wire with a 90 degrees Celsius rating would be sufficient, as it has an ampacity of 30 amps. Fourthly, apply any necessary correction and dirting factors. As mentioned earlier, correction factors must be applied to the ampacity rating of the wire when the ambient temperature exceeds 30 degrees Celsius. Dirting factors must be applied when multiple current-carrying conductors are bundled together in a raceway or cable. These factors reduce the ampacity of the wire to account for the increased heat generated by the conductors. Consult NEC Tables 310.15, V16 and 310.15. V3. To determine the appropriate correction and dirting factors for your specific installation. Fifthly, verify the temperature rating of the drive terminals. Ensure that the selected wire size and the applied correction and dirting factors do not result in a wire temperature that exceeds the 75 degrees Celsius rating of the drive terminals. If the wire temperature is likely to exceed 75 degrees Celsius, consider increasing the wire size or using a higher temperature rated wire. Sixthly, consult the manufacturer's specifications for both the wire and the drive to ensure that the wire is properly sized for the application. The manufacturer's specifications may provide additional guidance on wire sizing and temperature ratings. Seventhly, install the wiring in accordance with all applicable electrical codes and standards. Follow all NEC requirements for wire connections, grounding, and overcurrent protection. Using a larger wire size than strictly necessary based on the ampacity calculation alone can help dissipate heat more effectively. This is because a larger wire has a greater surface area, allowing it to radiate heat more efficiently into the surrounding environment. This can be particularly beneficial in situations where the ambient temperature is high or where the wires are bundled together, as these conditions can increase the wire temperature. Consider using a high temperature rated wire such as THWN2, which is also rated for 90 degrees Celsius but is also suitable for wet locations. This can provide an additional margin of safety and ensure that the wire temperature does not exceed the 75 degrees Celsius rating of the drive terminals. Ensure that the wire connections at the drive terminals are properly made and tightened. Loose or corroded connections can create resistance, which generates heat. Use appropriate wire connectors and tightening torques as specified by the manufacturer. Consider using a heat sink or other cooling device to reduce the temperature of the wire at the point of connection to the drive terminals. Heat sinks are designed to dissipate heat away from electrical components and can be particularly effective in reducing the temperature of wires and terminals. Another important consideration is the type of enclosure in which the variable frequency drive is installed. Enclosures can trap heat, which can increase the temperature of the wires and terminals. Ensure that the enclosure is adequately ventilated to allow heat to escape. In some cases, it may be necessary to install a fan or other cooling device to provide additional ventilation. In summary, while the 90 degrees Celsius rating of the THHN wire allows it to carry a certain amount of current, the 75 degrees Celsius rating of the drive terminals limits the maximum allowable temperature at the point of connection. Therefore, it is essential to select a wire size that is large enough to carry the required current without exceeding the 75 degrees Celsius temperature rating of the drive terminals, taking into account any applicable correction and directing factors. Consulting the manufacturer's specifications for both the wire and the drive is crucial to ensure that the wire is properly sized for the application and that all applicable electrical codes and standards are followed. Always prioritize safety and consult with a qualified electrician if you have any doubts or concerns. In addition to the points mentioned above, it is also important to consider the following one: the impedance of the wiring. The impedance of the wiring can affect the voltage drop in the current flow in the circuit. If the impedance is too high, it can cause the voltage to drop too low, which can damage the drive or other equipment. The impedance of the wiring can be reduced by using larger wires or by shortening the length of the wiring. 2. The grounding of the drive. The drive must be properly grounded to protect against electric shock. The grounding wire should be sized according to the NEC. 3. The overcurrent protection of the drive. The drive must be protected by an overcurrent device, such as a circuit breaker or fuse. The overcurrent device should be sized according to the NEC. 4. The harmonics generated by the drive. Drives can generate harmonics, which are distortions of the sine wave of the alternating current power. Harmonics can cause problems with other equipment in the electrical system. Harmonic filters can be used to reduce the amount of harmonics generated by the drive. 5. The line reactors and load reactors. Line reactors are used to protect the drive from voltage transients and surges. Load reactors are used to protect the motor from the harmonics generated by the drive. 6. The shielded cables. Shielded cables are used to reduce the amount of electromagnetic interference or EMI generated by the drive. EMI can interfere with other electronic equipment. 7. The proper torque. Terminations on electrical equipment must be properly torqued. Loose connections can cause arcing and overheating, which can lead to fires or equipment damage. 8. Using the correct tools. Only use tools that are rated for electrical work. This will help prevent electric shock. 9. The importance of safety. Electrical work can be dangerous. Always take precautions to protect yourself from electric shock. Wear safety glasses and gloves, and turn off the power before working on any electrical equipment. 10. The relevant documentation. Always refer to the relevant documentation for the drive, the wiring, and the other equipment in the system. This documentation will provide important information about the equipment and how to install it properly. Considering these points will help ensure that the drive is installed safely and properly, and that it will operate reliably for many years to come.